Good afternoon, students. This is the recap session from the previous units, 4 units. Okay, so in the mode of quiz. Okay, the first question. Okay, so all the questions are the based on gate, okay, previous gate problems. Post your answer in the chat box, else unmute your audio and tell me the answer. Two languages are here, L1 and L2. L1 concatenation with L2. Okay, what's the value of here, which represents concatenation? L1 dot L2. Okay, okay, B. So only two answer. What about others? The same one you two are picking. Okay, I will go for the answer. Yes, B only. Okay, this is actually very simple problem in the previous gate problems. Next question. Okay, so this is the non-deterministic finite automata. Okay, and the respective regular expressions are available in the picture. Just match the following. So one clue for this problem, which is you have to give more concentration over on uh, final state. Okay, how the strings are ended, how the regular expressions are ending. You have to match with the final state of the given NFA. Okay, posted answer. Just looking over on the final state and how the string is ended in the regular expression. Witness J choosing C, okay, either B or C. Okay, because both two options are starting with P equal to 1, right? So either B or C. So which one is the right one? Okay, if I will choose C means C. P for 1, the regular expression. So in P, your automata is ending with actually two final states. Okay, so this is the typical NFA. Here two final states and um, 0 for first one, it ends with 0, and the second final state also ends with 0, and the first one ends with 0 as well as 1 closer, right? So the common thing, we have taken out the common thing, 0, 1 closer, and Q for 2. See, only one final state in the NFA, and it ends with 0, right? 0. And R for 3. Here, see, ends with 1. Okay. only one final state and it ends with 1. So R for 3, S for 4, two final states and it ends with 1, 0 closure, okay, and 1. Okay, the common thing between these, okay, that is enough. Don't confuse with the remaining part. Okay, actually it has some algorithm, a predefined algorithm. What's the algorithm to convert um, finite automata to regular expression? Actually, for DFA to regular expression, we will have algorithm RAG method, right? DFA to deterministic finite automata to regular expression means exclusive RAG algorithm. And any other automata to regular expression means state elimination method, the right one. Okay. So you have to apply algorithm, but it will take a lot of time, right? So this based on the gate and as well as the MCQ part, some clues are there. You have to identify the right one. Okay. So C is the right one. Next, which one of the following languages over the alphabet 0, 1 is described by the regular expression? The input is regular expression. We have to find out the language description. 3A. Substring 0, 0 means the 0, 0 is not in the continuous manner, right? In between, either 0 as well as 1 may appear. So might be appear. It is possible. So Nandini had chosen C, Swati C. C for at least two zeros. I think C, which is the right one. So let me check. Okay, for this problem, C is the right one. Next. Which of the following are regular sets? Regular set means regular language. So far, we have learned regular language, context-free language, and recursive enumerable language, recursive language. Yes. So here it is about regular language. Post your answer. Regular language means a language which is accepted by automata, right? Context-free language means a language which is accepted by push-run automata. Post with question number. This is the 4. A 1 and 4. Okay. I think A is the right one. Let me check. Yes, A is the right one. Okay. See, in the first question, a power n, b power 2m, right? Here, no any constraints. Overall, m and n, just one constraint, both are greater than or equal to 0, right? And in the second one, a power n, b power m, that n equal to 2m. Some constraint is added, okay? So, probably you need some additional memory in the place of stack, okay? It's not coming the part of a regular expression because it has some limited memory. And the third one, a power n and b power n. Here also some constraints where n not equal to m. Okay. So due to the limited memory, regular set can't able to make this language, and it is not accepted. The last one, x, c, y. Here also the constraint is very simple. Both are belongs to a set of strings, a combination of a as well as b. Okay. So a, which is the right one. Next. This is fifth question. Match all items in the group 1 to group 2. Five B. Okay. Other. Just 1 minute. Okay, let me go for the answer. P is the right one. Good. So for B, P, which is 3, right? Regular expression.
Hi, everyone. So hope all are doing fine.
Regular expression. The application of regular expression, which is in the part of the first phase of the compiler. What's the first phase of the compiler? Lexical analysis. Okay. So compilation means a low-level language which is converted into machine understandable language, which is carried out using 7 phases. The first phase, which is the lexical analysis phase. So regular expression, that is your finite automata, which will play an important role in the lexical analysis. This is that we have already known in the first unit, right? Push-to automata means syntax analysis. Obviously, which is syntax analysis. Okay, because it has a parse tree. Using parsing only the syntax is analyzed. Okay, but semantics which is not possible in using parse tree. Which is the third phase. In the second phase, which is syntax analysis. So context-free languages played a major role in the second phase, syntax analysis, by using the parsing. Okay, so these two is available in our syllabus, right? So we have P 3 and Q 1. Okay, we have to choose P3, Q1 without having additional knowledge. A basic syllabus knowledge which is enough. Then R, which is for code optimization, data flow analysis, which is not actually, it is not in the AU Anna University syllabus. Okay, and register allocation for as which is code generation. Okay, you have to learn additional things from this course. Which one of the following is false? There is a unique minimal DFA for every regular language. Every NFA can be converted to an equivalent PDA. Complement of every context-free language is recursive. Every non-deterministic PDA can be converted to an equivalent deterministic PDA. Which one of the following is false? Okay, false. D. Okay. Positive answer along with the question number. Yes, D is the right one. Every non-deterministic PDA can be converted to an equivalent deterministic PDA. No. Okay. Actually, this point, actually, I have mentioned this point while I'm taking some problems in question automata. Okay. We can't convert all NPDA to DPDA. Okay, it's not possible. W has even number of ones. Okay. A set of all bit strings with even number of ones. Which one of the regular expression below represents L? 70. Okay. Any other answer? Even number of ones. Kindly revise your answer, Nandini. Because in D, one this is the probability, definitely a probability one, and very tricky one. It seems all the answers are right one, but very tricky. So what about others? Vignesh, Sanjay, B. Okay. What about Swati? Okay. Let me check the answer. B is the right one. Okay. C in B, um, actually the one, even number of one, but not constrained over on zero. In A part, uh, both zero are in between the. Actually, this is the very tricky one, right? So actually, B is the right one. It starts with zero. Okay. It starts with zero and zero closure. Zero closure means it may starts with zero or sometimes epsilon. Epsilon is also added. So that case is also added here. That is why they have chosen B rather than A. In A, such cases are not added. Which one is starting? What about the starting case? Here the starting is 0. Sometimes it may starts with 1. When it is closer means epsilon, right? But here the C option, the one which is in the closer state. So closer means epsilon which is also added. So it may comes to sometimes uh, odd cases. It also accepts odd cases too. The same thing happened to D also. Okay, so A B, the probability will become to be A as well as B. Okay, as B which is considered the zero case as additional. Okay, so B is the right one. Okay, it's very tricky because both A and B both are coming true as per the problem statement given in that problem. Okay, but either way, B means 100 of 100. Okay, next. This is almost very easy one, right? We have already gone through these type of quizzes in your weekly test. Question answer along with the question number. Okay. Okay, Rakshmi. The most of the students are prefer to choose C, right? Okay. C is the right one. C. C. The C part which it doesn't include number 3, right? So C, BAA, then next AA, then AB, then AA, then next AA. One B is left over here. Okay, that is why B is not a given language. Okay, next. What is the complement of the language accepted by the NFA shown below? The What is the complement of the language accepted by the NFA? Here your NFA is accepted by A, right? Only two uh, alphabets are available here. Only A as well as epsilon. No more alphabets are added here. So this NFA is accepted by A. So what's the complement? If you are able to understand the question, this NFA is accepted by A as this NFA has only two alphabet A as well as epsilon. So what's the complement? Complement means the reverse. Mm, okay, it is also a very tricky one. Right? Okay, let me check the answer. B. Epsilon. Because this NFA has only two alphabets. Okay, A as well as that is input. A as well as epsilon. As this NFA is accepted by A, so when I'm going to take complement means the reverse part, it is accepted by the epsilon. Okay, there. If NFA this accepted by A means NFA bar which is accepted by epsilon. What is the set of reachable states for the input state? This is also very interesting and easy one. No more difficult in this diagram. What is the set of reachable states for the input state? 0, 0, 1, 1. Okay, others. Zero zero one one. The string is 0011. Okay. Yes, don't think too much. Nandini. Yes. Now only he will come. Actually, B. I think Nandini had some confusion still. He will reply immediate answer for the big problem. Okay. Mostly are preferred B, right? Let me check. A. Who is A? Gayatri, right? C. 0011, right? So, what is the set of reachable states? See here, 0, 0, 1, 1. Q naught is added. Okay. 0, 0, 1, 1. Q1 is added. Okay. 0, 0, 1, 1. Q2 is added. So A is the right one. Okay. And add Q2 because 0, 0, 1, 1. This is D. This is NFA, not a DFA. This is NFA, non-deterministic finite automata. So for a input, it has more than one transaction is possible. In DFA, it's not possible. A unique transaction for any input, but in NFA, for one, it has two more transaction, right? So A is the right one. Which of the following is true for the language A power P where P is a prime? Kindly recall the closure properties of previous language and post your answer. For level B, is neither regular nor context free, but except for the termination. Okay. What about others? See, recall the closure property of context free. I think in context free only I will take this A power P prime number problem for proving that the given language is not context free. Just kindly recall. So actually, this is the problem. A power p where p is a prime. This is the problem which comes under both regular expression as context free in the part of pumping lemma. What's the concept of pumping lemma? It is the concept to prove a language is not regular. It is the concept to prove a language is not context free, right? In both category, this problem is applicable. So this action, so the, regular language impossible. Okay, as well as for a single stack, we can't have this type of problem using a single stack. So context-free language, or Houston automata, which is also not possible. Okay, Turing machine. So Turing machine means all kind of operations you can perform using Turing machine. Using the infinite tape concept. Okay, so let me check the answer. D is the right one. Okay, so is the right one D Gayatri? Again Gayatri. Okay. Today, pre-session is number 1. Recall the theorems as well as in the previous sessions. I too um, had some demo on a lot of theorems in Unit 5, right? D. Okay. Anyone? I think D. If they are, this is very simple one. If they have added recursive enumerable means, it may we might have some confusion state. But here they have added only recursive. Remaining part about regular context free, context sensitive, right? So T1. Okay. L equal to L intersection with L2, where L1 and L2 are languages as defined below. First, you have to identify the languages. Which type of language, which is L1 and L2, both are which type of language. So, based on your calculation, what about the intersection? First, L1. You have to find out the type of language L1. Which type L1 is? Whether it is regular or it is context free or it is recursive. I don't think too much in the part of recursive because see, yes, context free. What about L2? Same. C. Mm, no, yes, regular, right? L2, which is regular. Okay, so L1, which is context free, L2, which is regular. So recall the content of closure properties of context free. So context free language intersection with regular language, what is the output? This is one of the property, important property. B. Let me check that. C. Okay. So just go, once the class is over, just go through the closure property of context free languages. In one closure property, which is actually um, context free languages, which is not closed under intersection. Okay, actually, it is not closed under intersection. It is closed under only union, concatenation, as well as clean closure. Okay, but the context free languages intersection with regular language means which gives context free only. Okay, so C is the answer. Thank you, students. Okay, you can leave the classroom. Thank you so much.